So we've looked at lists and dates as examples of mutable objects. The next mutable object we're going to look at is an iterator. An iterator is an object that steps through a collection of elements and returns each of those elements one by one. Iterators are automatically used behind the scenes in Java when you're using a for loop to step through a list or an array. So if you have a list and you write a for loop that says you want to look at each element of that list, then the Java compiler actually rewrites that to something kind of like this. It creates an iterator object by calling a method on the list that returns a new object of type iterator. And then the loop repeatedly calls hasNext to find out if the iterator has gotten to the end. And if it hasn't, it asks the iterator, calls the iterator's next method to get the next element from that list. So this line here turns into these three lines here. And there's this iterator, which is a mutable object that basically represents a position through the list, moving through the list. There are two important methods on an iterator. Next returns the next element in the collection and advances the pointer. And hasNext tests whether you've gotten to the end of the collection or not. So this next method is actually a mutator. It changes what the iterator means. It changes its value. It changes what hasNext and next will return when you call them another time. So to better understand how an iterator works, here's a simple implementation of an iterator that only works on array lists of strings. We don't want to use myIterator in general. You actually want to use the ArrayList's own iterator object, but we're writing this for the sake of for understanding how it works on a simple example. So this uses a few Java language features that maybe you haven't seen much up to this point, so we're going to explain them very briefly. Instance variables, which are also called fields, are variables that are associated with each instance, each object value of a class. So a myIterator object is going to have two instance variables in it, a list and an index. So this list points to the list of strings that we're actually iterating over. The iterator needs to hold on to that. An index is the current value, the current index in that list that the iterator is currently returning. And next is going to advance that, and hasNext is going to test whether that's at the end of the list. There's also a constructor here, and a constructor is a special kind of method that makes a new value, a new instance of the class. You should have seen constructors already in Python as well. This one will take the list that we want to iterate over as a parameter, and it holds on to that. It stores it in the instance variable. And you notice that we're using here the this keyword. This is actually Java's version of the self keyword in Python. One of the features of Java, though, you may know from Python that self normally has to be passed as one of the arguments into a constructor or an instance method. In Java, this is implicit. The way that you know that, that you're able to use it is that constructor and instance method does not have static here. So the absence of static means that you have access to a this object, and you can use this to refer to it, and in particular to access its fields like list and index, and that's what's happening here. So that's a constructor. Well, here's one of the instance methods. Remember, we need two in an iterator. We need hasNext that tests whether at the end, and next that returns the next value. And again, we know these are instance methods because they don't have a static. They will have to be called on an instance of the myIterator class, and that will become the this object when you're inside this method. But now notice, in this particular case, we're not using this. We're not referring to this. Java allows us to simply refer implicitly to the fields, to the instance variables of a class if we're inside an instance method. So this index is actually referring to that instance variable. We could have written this .index here in the same way we wrote it here. We chose not to, just for convenience, and you'll see many Java programmers omitting the this. So we also have, by the way, some differences between private and public. Private things, private classes and variables can only be accessed within the text of the class that they belong to. So that means that this list and this index can only be seen and accessed from within this myIterator class. Whereas public ones, like the constructor and like these methods, can be called from anywhere. And we've talked about final before. Final makes this reference, this list variable, immutable. It means that it can only ever point to that list. So in particular, when we draw this snapshot diagram that shows a particular instance of myIterator with its fields, with its instance variables, its list variable points to a particular array list, and that's a double arrow because it's final. And that means that this arrow can never actually change. But notice that the array list object that it points to is mutable, right? It doesn't have a double border around it. Lists are in general mutable, so elements can be changed within it. Declaring this list final has no effect on whether this object is mutable or immutable. Now, why do iterators exist? Well, there are many kinds of collection data structures, linked lists, and maps, and hash tables, and arrays, and they each have a different kind of internal representation. The advantage of the iterator idea is that we now have a single uniform way to access them all, an object with methods next and hasNext. So the client code can be much simpler, and we can use various different collections without changing the code that is using that collection. So most modern languages, including Python and C# and Ruby, as well as Java, have the notion of an iterator. It's a very effective design pattern. Design patterns are a well-tested solution to a common problem. And we'll see many other design patterns as we move through the course.